Okay, so for our critical value approach, we have to figure out what our rejection rule is. So because our hypothesis was set up with the null hypothesis being greater than or equal to 3 pounds of coffee, our alternative hypothesis was that it would be less than 3 pounds of coffee. Our rejection rule then is if our test statistic comes back as less than or equal to negative 2.33, then we reject the null hypothesis. Well, our test statistic came back as negative 2.67. So remember that we're talking about a negative value here. So if negative 2.33 is right here, then negative 2.67 is less than negative 2.33. So it's going to be on the left side of the z-score that we had as our critical value z-score. So in this case, we reject the null hypothesis because our test statistic is less than or equal to 2.33. Negative 2.67 is less than negative 2.33. That's our critical value approach. Now, if we're looking at the p-value approach, excuse me, then what we're looking at is the probability. So that p-value approach is the probability. Let's go ahead and set up our rejection rule for the p-value approach. So with our p-value, we're looking at our alpha, again, at 0.01. What this is telling us is that we want to make sure that we are not making a false claim against this company. Our critical area is down here, again, same as it was in the other. And this value here, critical value, is 0.01. That means with 99% confidence that the test statistic would fall in this area right here. So what we're testing is to make sure to determine whether it's falling lower than our critical value. So for this rejection rule, we're going to look at the probability that's associated with our negative 2.33, which is this value right here, and our test statistic. So if we have a negative 2.67, we can go to the table in our book, or we can use an Excel formula. So to figure out the probability that's associated with negative 2.67, we're going to go to Excel, or you can use the table at the back of your book. In Excel, you would put the formula equals norm, N-O-R-M, dot D-I-S-T, I'm sorry, norm.s dot D-I-S-T. And then in your parenthesis, you're going to put your z value. So in this case, it is a negative 2.67. It is very important that you put that negative symbol in there with your z-score, or you will not get the right probability. So you put negative 2.67, and then your cumulative value is true. When you do that, you're going to end up with a probability of 0.0038. So next thing that we have to do is to determine, is 0.0038 less than our critical value of 0.01? If our probability that's returned from Excel is less than 0.01, we are going to reject the null hypothesis. And in this case, 0.0038 is indeed less than 0.01. So we are going to reject the null hypothesis. Again, this is the process that we use when we're looking to test a manufacturer's claim. Remember that the manufacturer is claiming that their coffee cans, the average is 3 pounds. So they're saying that the majority of, they're saying that there's at least 3 pounds in each can. We take a sample. When we take our sample, remember, sampling doesn't give us a positive yes or a positive no. It's only showing us a representation of the population. So it's important that we make sure that we are using an alpha level that will give us the lowest probability of making a type 1 error, of rejecting the null hypothesis when it is actually true. So again, our steps that we're going to take, step 1 is that we're going to figure out what our null hypothesis and our alternative hypothesis is. Step 2, get this down here where you can see it. Step 2, we have to set our significance level, our alpha level. Step 3, we collect the data and we compute the value of our test statistic. For critical value approach, you're going to use the level of significance to determine the critical value in the rejection rule. So if the critical value, okay, in this case, ours was negative 2.67. That was our test statistic. Negative 2.67 is indeed less than our negative 2.33 for our critical value of alpha 0.1. If we're using the p-value approach, then we're going to look at the probability. And again, you can use the probability that's in the table, or you can use Excel and compute it with the Excel formula, which is norm.s.dist. In parentheses, this is your z-score, and the cumulative value that you're going to use is true. This completes the lecture portion for testing population, testing hypotheses using population mean with the standard deviation known.